It is fantastic to see so many of you guys here. All right, let's dive in. So welcome to the MLOps Live webinar series, your go-to space for discussing how to bring data science into production and unlocking real business value from AI. We're thrilled that you can join us today for what is going to be a really special session. I'm Edith. I'm the head of community and open source marketing at Iguazio, an AI startup that was acquired by McKinsey back in 2023. Today's topic is about how to manage thousands of real-time models in production, a real client example from Seagate. It's been 2 years since we had Seagate here join us on this webinar series, and we're thrilled to have you back. It's been a lot has happened since then, and today they will be sharing the progress that they've made in scaling their ML pipeline and automating their MLOps processes. We'll also get a glimpse into how they're now managing thousands of AI models in production. I'm excited to introduce our first speaker, Kaegan Casey, an AI ML solutions architect at Seagate. Kaegan will walk us through Seagate's MLOps journey, the challenges they face, how they're tackling them, and what they've learned along the way. He'll also be sharing 2 fascinating real-world use cases. After Kaegan's talk, we'll take a quick break and run a short poll. Then we'll hand it over to Gilad Shapira, Customer Success Engineer at Iguazio, who will dive into a live demo. Gilad will show us exactly how to run thousands of models simultaneously in production, with a hands-on code example tied directly to Kaegan's use cases. And of course, we'll wrap things up with a live Q&A. So feel free to drop your questions in the chat, in the Q&A tab as we go on. A few housekeeping items before we begin. This session is recorded, and a link will be shared with you afterwards. Don't worry if you miss anything, we've got you covered. We'll be taking your questions throughout the session, which is always one of the highlights of these webinars. So please take the time to drop your questions in the Q&A tab on the bottom of your screen, and we'll try to address as many as possible. We've also added one poll to this session. Your input is valuable in shaping the future webinars, and we really want to hear from you. So we encourage you to participate. We'll also share the poll results live at the end of the webinar. Lastly, we invite you to join our MLOps Live community to keep the conversation going after the session. We'll share the link in the chat now for easy access. All right, without further ado, I want to hand it over to Kaegan to get us started.
Yeah, thank you, Edith. So I'll start sharing my screen. Okay. And yep, hopefully you can see my screen. Just let me know if you can't, I guess. Yeah, thank you for the introduction and everything. So like Edith mentioned, I'm an AI and ML solutions architect at Seagate Technology. Basically, what my entire kind of team does is we partner with different functional areas of the business to identify high-value machine learning and AI projects, and then we help to design, implement, and scale those projects over time and ensure their success, basically, at the company. And so today, we went through the agenda, but I'll be kind of starting with our MLOps journey overall with Iguazio and kind of the challenges that we faced, how Iguazio has helped solve them, and then I'll get into the 2 kind of use cases that exemplify that as well. So basically, Seagate has been working with Iguazio for roughly 4 years now. We began looking for an MLOps solution around 2021 when MLOps was getting very, very popular and becoming even more of a necessity, really, in the space. So we started looking at several different vendors. We ended up going with Iguazio and started working with them later on due to several reasons, which I'll get into throughout the presentation and kind of highlight. And really, initially, we just started trying to just understand the technology and the API in regards to how we should use it, right? So initially, there was about 4 to 5 data scientists or MLOps engineers and about 4 infrastructure administrators. They were generally rotating, like, 2 of them would be actively administrating the cluster and kind of getting new clusters set up and things like that, and kind of moving from there. So we've since grown to like 15 to 20 users in present day, roughly. But initially, we were just understanding the technology and the API. We were kind of implementing dozens of like small use cases or proof of concepts to try to understand like our workflow, how we need to maybe mock things out with testing our code and things like that as well, and just understanding which parts of the platform work for our use cases and work for our general team collaboration as well. So we started out with a lot of collaboration, solution design with the customer success team as well at Iguazio, who's been fantastic, like Galad is as well. And a lot of initial feature requests. So it was really wonderful. That some of the features we requested were things that could be implemented very quickly. Others took a lot longer. At this point, every single feature we've requested has gotten implemented. So that's been really encouraging, and it's been really wonderful to work with a partner that like listens and tries to implement things based on feedback and kind of comes from that continuous improvement mindset as well. And then we started really deploying our projects fully into production. So I myself have only been working with Iguazio for about 2.5 years now. When I first started working with Iguazio, it took me probably 6 months to like learn, understand, and then start deploying some of these projects into production where engineers would actually be using them more in a more hands-on fashion, for example. So there is a slight kind of like initial steep learning curve to Iguazio, and that is mainly due to its extendability, its flexibility, and its complexity. And I think those are all good things, right? Like I would rather a tool that is highly complicated, or I would rather a tool that is complex but flexible and extendable over something that is overly simplistic that is easy to pick up. But at a certain point, your needs are gonna exceed what the tool can do, and you have to go find another tool or patch together other existing tools and make them work, etc. So I think that the complexity and the initial steep learning curve with Iguazio is warranted, and it has come a long way since 4 years ago, even, right, where the API is just continually getting better, the documentation's getting better. They have plenty of videos showing you how to work with the tool a lot more as well, and the platform as a whole. So it's only getting better and better. And I'll go through some of what we've done to even further increase that at our own company based on the style that we like to interact with it and operate with it as well. So since then, as I said, we've been onboarding more users, and then we've been starting to explore kind of new technology and integration with LLMs and Gen AI. It's been really wonderful because we get to just focus on the implementation part of these solutions, right? So how do we get results in the factory? How do we make them actually usable? How do we actually take action based on those results? And Iguazio gets to focus on, okay, hey, there's new technology out there. Like, how do we do MLOps for LLMs? And things like that. So it takes a lot of that burden off of us as well, which has been wonderful because you could do so much more with such a smaller team. And then, since then we've kind of grown to 2 cloud and 1 on-prem clusters. I think the ability of Iguazio to be able to be on-prem is super important and should be highlighted as well. Because especially in a manufacturing use case, you for a lot of your projects, if you have things that the manufacturing floor relies on and you lose connectivity to the cloud for whatever reason, that could be detrimental. So it is a pretty strong requirement that is like very specific for certain industries, and specifically in manufacturing, can be very important for having the ability to be on-prem as well and having that flexibility. So that's the overall timeline to today. So some general MLOps challenges that Iguazio has helped to overcome, and I'll get into these throughout the presentation, but this is just like a high-level view. It's basically the first one that I think a lot of people are familiar with, or should be, is the gap between experimentation and deployment. It's kind of, in my opinion, that's like the #1 reason we go to MLOps, is it helps manage this and reduce that gap significantly. And specifically, there's this slow feedback loop, right? So um, to go from testing something locally or on a VM to deploying it at scale on a Kubernetes cluster can often take time, and that slow feedback loop is where you lose a lot of momentum in your projects. And so what Iguazio allows us to do is really go from testing code locally to running at scale on a remote cluster like within minutes. So I can get a new intern in here, and within 2 weeks they're running something locally with a minimal size data set, and then deploying it on the cluster to scale to multiple gigs of data, for example, to do more formal testing. From there, also, you're really just testing the implementation scalability from the beginning. So, like whether it's a new project or just a new feature on an existing project, you can test that scalability right from the start, as opposed to spending a long time on the proof of concept and the research and not really understanding how will that actually scale in practicality with the factory, kind of an idea. So a lot of the other ones are pretty standardized. There wasn't really a unified experiment tracking or collaboration at Seagate. There was a lot of people using a lot of open source tools very effectively, but there was a divergence there among teams. And so Iguazio really allows us to have shared projects, detailed logging of parameters, metrics, and machine learning artifacts, and especially the artifact versioning using like labels and tags and being able to associate data. So like if I train a model and save it, being able to save the encoder that's used with that model, et cetera, has been super beneficial, and be able to return that during inference. Next would just be like integration. So Seagate has been around for like over 45 years. We're kind of like a legacy manufacturing company. And what comes with that is a diverse set of technologies that are used across our factories. And that diversity brings with it complexity. And what Iguazio allows us to do is connect all of that, really. So like we have a lot of diverse factory inputs and outputs for real-time or batch inferencing of data. And we have a lot of options for either connecting to them in real time or, anything that we need to customize, we can customize basically through a nucleo function, through an ML run function, et cetera. I already mentioned on-prem versus cloud. The other big one is monitoring. So monitoring is a huge one where, there's a lot of bespoke monitoring that might get set up per use case or per application, depending on where it's deployed, depending on the infrastructure available and the logging available and the metrics that you can get from the particular infrastructure that you're deployed on. And what Iguazio allows us is to standardize the application logs, the metric outputs, so that everything can benefit from Prometheus and Grafana monitoring, and you get the log forwarding out of the box to your preferred log management vendor out of the box, basically. So that's been super helpful as well and very underrated. And then lastly would be the vendor support. So this is always kind of like a major question when you're thinking about like building versus buying an MLOps solution. And I think the vendor support is also something that is highly underrated, where when you have this highly responsive kind of support team collaborating with your infrastructure team and ensuring the high availability of the whole system, it's super beneficial to be able to have someone that you can go to, not just to make sure that everything's up and running, but also things like upgrades and migrations and things like that. So upgrading even just specific components that you don't get when you're using like an open source solution, for example, and where it can be a lot more complicated to upgrade and test those things, especially across different deployments. And help with issue resolution and solution design as well. So those are some general MLOps challenges. We'll get into even more as we get into each project. So I'm just going to cover super briefly some just basic hard drive terminology as well. And that's basically, just things I'm going to be talking about that's relevant to both of these projects, basically. So the first thing is just a hard drive is made up of many different parts. Of course, the main component that we're going to be discussing today is a wafer. And so a wafer is a ceramic disc that's made up of layers of ceramic substrate, and they're sequentially layered on top of each other. And basically, one wafer can equal 100,000 recording heads for a hard drive. What makes this so complicated and important is that the layering process can include more than 2,800 steps that form these patterns, and then a single wafer can take anywhere from 4 to 8 months to complete. So the cycle time on this is incredibly long. It's incredibly complex, and the room for error is small. If we end up scrapping one of these, it's a significant investment in time and money. And so both of these projects today we'll be discussing our wafer factories and our wafer manufacturing process and how to make that more efficient and more healthy over time, basically. So the first one is AMKPIV. AMKPIV stands for Autonomous Monitoring of KPIV Data. KPIV stands for Key Process Input Variable. But basically they're IoT sensors, right? So when we have these tool sets that are processing a particular wafer, we have these IoT sensors that are monitoring the like the current and the voltage and the pressure of the tool set. And basically it's like every 2 seconds, take a measurement of the current or the voltage or the pressure, et cetera. And while it's processing a particular wafer or product or commodity. And so what this is doing is this is an anomaly detection system that is set up for like tool health monitoring on this KPIV kind of IoT sensor data, essentially. And so the scope, what that means practically is like the scope of this is, there's 24 plus different groups of processing tools that are running 24/7. And those are just groups of tools. So there's many tools within them. They're running 24/7 and they're generating tens of millions of samples of IoT time series data per day that must be monitored in real time. Samples just meaning like, the number of rows even if we look at that. So like every 2 seconds of taking a measurement. kind of an idea. For that, so it's like a very large scope. We are not deployed to all 24 tools today, which you'll see in a moment. But I'll show you the scale that we're at currently, and we're rapidly expanding from there. The amount of resources that we have for this project right now is, 2 data scientists or MLOps engineers, 1 application developer, and dozens of equipment and process engineers to give us feedback, review alerts, take action on those alerts, and kind of monitor the health of their factory over time, right? Of their processes over time. So my colleague who works on this project with me always refers to Iguazio as kind of like a force multiplier, where it's kind of like basically you could do a whole lot with a much smaller team, especially. So that's where we found it extremely effective, where you can have a data scientist and an MLOps engineer kind of just work together and get as much as possible out of it, basically. So there's a lot of opportunities for value realization in this project. Like I said, the main one being that cost reduction through scrap avoidance. So if we know that our tools are operating as expected, as they were historically when they process a particular wafer, they're doing something according to like a recipe. It's like you're baking a cake. So it's like if I bake the cake every single time, is the heat in the oven the same? Is it on the same rack in the oven? Did I use the same amount of flour and eggs, etc.? And so really that's what this system is doing is it's like last time when we baked this cake, what did it look like? Was it the same or different? If it's significantly different, we're going to give you an alert for that, and you're going to have to investigate it and see where that goes. So it's a trend idea. It's not necessarily like you're going to predict that something's going to fail ahead of time, but it will minimize the scope of the impact if something is causing a defect. Some type of processing is causing a defect, or it allow you to do like to schedule maintenance planning if something like could cause a defect in the future, but you can wait to address the issue as well. So lots of different opportunities here. There's even more than this listed on the slide as well. In terms of an architecture diagram, so this is the rough overall architecture. Hopefully you could see it. It might be a little bit blurry, but I think you can see it for the most part. On the left, you can kind of see that there is a few different technologies highlighted, and we're going to be starting in the upper left and kind of working our way over, down, and then back up. But the first kind of step in our process is model configuration definition. And basically what that means is it's essentially it's the only manual part of our entire process. And it's a one-time initial setup when we deploy to a new tool set. And it can be dialed in over time as needed. But it's basically the blueprint. So it's like what should be monitored according to what cake we're baking, right? And then with which models should be monitoring those things, basically. So it's like an initial blueprint. It's relatively easy. It usually doesn't take more than a week. And then it makes its way into a database. From there, we have everything else automated. So then we are then automating the generation of model configurations. In this case, a configuration is really just like if I'm baking a cake, it's the recipe, right? So I might make a lemon cake or a chocolate cake or something like that. And so that's what it is. It's saying, hey, for this particular configuration of the things we need to do, the thing we need to build, the way this tool operates, etc., what models need to be trained and what are their statuses, right? So is there enough data to train this model? If so, then it needs to be trained, and it needs to be marked to be trained, basically. Has this model already been trained, in which case it should be live and available for inference? Does the model need to be retrained, etc.? So this is pulling from what they're running historically in the factory. It's adding new configurations if new things are being run in the factory, new cakes are being baked. And then it's inserting them into a table that controls their state and what models need to be trained or not. From there, we technically have 2 algorithms. One of them is a pre-trained algorithm, and the other one is it's trained live, like on the fly, using kind of like a rolling window time frame. And so the one that is pre-trained will then get kicked off for training. And that is done using MLRun, and it's an MLRun job that then gets put into like a Kubeflow pipeline because MLRun integrates directly with Kubeflow, so that's super helpful. And that allows us to train as many as we want in parallel. So for us, like you could train thousands of models. You could basically however much you have for compute in parallel with at most n running at a given time, right? So I could submit a job for like a workflow for 1,000 models, and I can have like 2 or 5 running in parallel using a GPU or something. From that just changes the state, right? So hey, that model has now been trained. It should be available for inference. Our models, the way that it works is they are, as soon as those models change their state in this database, so for the one that is pre-trained, as soon as it is trained, for the other one, as soon as it is available just in this database, they are available for inference automatically. And the way we're doing that is because we have kind of like a unique model serving architecture here, or just something that allows us to scale to, a high number of models when latency is less of a concern. And that we just call it like on-demand serving. But basically it's like, data will come in from our factory. We just processed a particular tool, a particular wafer on a particular tool. It has all the contextual information. Hey, this is the cake we're baking, etc. We then will have a service, like a Nucleo serverless function, that will convert that to a RabbitMQ stream, that data, and just write it back to a RabbitMQ, a V3IO stream. So it reads from RabbitMQ, writes it to a V3IO stream. And then that V3IO stream, it's very similar to Kafka. We just use V3IO because it's like an internal streaming mechanism that is like native to the platform. It's a bit easier for me to just set up and control instead of managing a separate Kafka instance, etc. And then it writes to it, and then we have a separate Nucleo serverless function that will enrich that payload, that data, with what models need to be applied to it, right? So, hey, we're baking this cake. We have these models. Those models need to be applied to it. And then we write to another V3IO stream. And then basically each of these independent Nucleo functions can have their own replicas, can be scaled up as needed. And they will load their models on demand. So meaning like whatever it says in the data, I'm going to go grab that model from Iguazio, load it right away, perform inference, and then write back to a database or a stream, etc. So that's kind of like the on-demand loading where we don't have to load, 3,000 or more models into memory. And we can still get relatively quick results when latency is less of a concern, at least. So this project has a higher latency requirement, where it's like we have to get a response within 180 seconds. Sometimes it can be even longer than that if we choose. It's a much softer requirement than on the other project that we'll talk about today. So each of those can be scaled up independently. They have their own consumer groups on the V3IO stream, so they won't pull, like one model won't pull records from another model, etc. And then they post back to RabbitMQ for factory control. So it's like, do we need to shut down a tool, etc., automatically based on whatever engineers have configured. Other than that, they also write to a database, which then combines their results and summarizes them in a dashboard as well. And that's what the main engineers actually interact with, is that dashboard. So I'm sure there's questions about this, so post them in the chat and we could talk about them at the end, hopefully. All right, so this is the rough project scale over 90 days from November to February. So we're operating at roughly 35K inferences per day across 2 factories, 9 tool sets, and 2 algorithms. So like I said, there's 24 different process tool sets. We're deployed right now to only 9 of those, basically. So that's why, it's not fully at scale where it's processing that amount of data, but it gives you kind of a rough idea of where we're at today, and we could scale very quickly from here, basically, with what we set up. 35K might not feel like a lot to a lot of people, especially if you are at more of like a traditional kind of software company, or where you're servicing like millions of requests a day. Eventually this will get up to that point. But today, at least, for us, the true challenge here isn't necessarily the number of inferences per day, it's the variety of data that we operate with. And I think that's super common for a lot of manufacturing companies in general. We have certain components in our process that do have way more volume than they have variety. It's just for this particular component, being a wafer, there is a significant amount of variety that makes it extremely complicated to manage that many models that have to have, again, like it's a very diverse set of cakes that we're trying to monitor the baking of, if that makes sense. So that's where the real challenge comes in. Scale is still a problem. It's still a challenge, I should say, but it's something that I think we largely have figured out. Variety is the challenge. So I feel super confident with the system we built that we can get up to the full amount of tool sets. It's just about managing the complexity and the nuances as it relates to each tool set from there. So like I said, we're managing a large number of pre-trained models. Basically, initially we were managing even more, but we have since deprecated an algorithm that was just kind of like ineffective and infeasible as we started to scale. I wanted to mainly show that because we were managing even more than like 3,000, which is what we're managing today, across those 9 tool sets, and kind of the impact that it had, in terms of being able to train that parallelly and things like that. So, I don't want anyone to go and say I have to deploy thousands of models because that's what other companies are doing. I think that we all are everyone's goal is going to be like deploy as few models as possible and manage as few models as possible, because I think that's just like hopefully where we're all converging towards. But for our particular process, we had to go this route due to performance reasons. So the only way we could get the performance that we desired at the level of granularity that we needed, again, because of the variety of the data that we're dealing with, we had to start training models at this low level. And what has been great is we've been able to do that, and we've been able to scale up to that. You can see here on average, for different tool sets, it kind of depends on our response times. But a lot of this is driven up by the second algorithm that is being trained live, and it's actually querying a small amount of data. So that takes a bit longer, whereas the first algorithm that is pre-trained, it returns a response in like a second. Like 1.2 seconds is its average across all tool sets. So even with this on-demand loading, it's super quick. With through all this, we're monitoring, about 425,000 unique processes or sensors today. And that is like those configurations that I'm talking about as well. So next, I kind of want to talk about like how we interact with Iguazio, because I think it could be super interesting if other people are interacting with Iguazio and ML Run, and it could be beneficial to like the community as a whole. And it's just like what works for us, right? So it might be different for you, but this is something that has worked really well at our company with our style of development, which is a bit more like monolithic when it's project development. But for us, this has worked really well with Iguazio, where we kind of created this template with a lot of flexibility, scalability, and extendability in mind. And that's kind of like the core thing at the beginning of everything that we do, that we try to implement. So how it works is basically, you have this shared set of applications. They each have their own kind of requirements and code for training or serving, etc. And then they have a shared set of utilities that they can all pull from, of course. And then data scientists or MLOps engineers can test all of their code locally if they want in their preferred environment, whether it's a VM or their just local laptop, even if they're working with a really small amount of data. And then they can go from there. And so it keeps them really comfortable, but then they can scale when they want. So you're able to use these orchestration scripts basically to deploy model training, model serving, or any batch applications or real-time applications that you want onto Iguazio very easily. Excuse me. Um, and so what that allows you to do is, again, you can go from developing locally very comfortably, debugging even locally, and testing to scaling it up to the cluster within a matter of minutes. So it's very effective. And those are all pulling from configuration that's kind of different for development, production, staging, etc. This is all managed through a centralized Git repository. And then we have some automated task management for like tests and environment creation and all of that. So this is what it looks like visually. Apologies, I have a tickle in my throat. Um, so this is what it all looks like visually. So I wanted to give you an idea, like a bit more practically, and what I'm able to share at least, of what our actual repository looks like. So it looks super similar to this. And you can see right in the root of the repository, there's the orchestration batch script. Basically, so that's like any batch application, right? If I want to just run something every 10 minutes, run something every hour, it could be deployed using that. For example, we have an orchestration model serving and model training because they're a little bit different. And then the one that isn't shown here is like an orchestration serverless. So it's like any real-time serverless function that needs to be deployed, that can be up 100% of the time servicing requests, basically. From there, we have kind of like project initialization, stream management, requirements, etc. The requirements in the root of the repository are basically for just orchestrating and deploying stuff. So it's like only ML run is needed and only a few bare minimum things are needed to actually deploy things. Whereas each individual application might have their own requirements. And those are all stored in this source folder. You can see our different kind of applications and then the shared set of utils as well. So each of these will have their own set of requirements and, Python code, etc. But this kind of monolithic approach to the repository structuring, it's good for like smaller teams like that we have here at Seagate and kind of like quick iteration and quick testing of every single component across this entire system for keeping it all in one place, etc. So this has been super effective with working with Iguazio, and Iguazio is great for CI/CD and maps like directly to a Git repository, one-to-ones, like a project in Iguazio can map directly to a Git repository. So I think this really benefits the general style that Iguazio operates under as well, is what I would say. Okay, cool. Yeah, if there's questions about that as well, I'm happy to answer them at the end. Okay, so for this particular project, a lot of the challenges that we're facing that Iguazio has helped us to solve, I've already kind of covered. So it's basically the large number of pre-trained models makes loading them into memory challenging, especially once we scale above the 9 tool sets we're at today. Managing large batches of training can be handled with Kubeflow. And then training these models live with real-time inference, you have to really replicate those functions out. So it's really helpful to have something like Nucleo that can replicate that out and very easily scale up and down based on what you need, basically. Flexibility is also super important. So being able to have these kind of complex serving DAGs, diverse stream trigger options, like being able to connect to RabbitMQ or Kafka or V3AO streams, and then having customizable model serving functions as well. All right, so the next use case that we're going to cover is smart sampling. So smart sampling is basically a generalized ML approach to determine if a commodity should be measured or not. In this case, a particular wafer. So like I said, it's like roughly 2,600 steps. It can be as high as 2,800, and it's getting even more steps to build a wafer, right? Like steps in a recipe to build a wafer. And about 40% of those are just measuring, right? So it's like after I do this to the cake, I need to like measure the temperature, etc. Um, these routes are getting longer, they're increasing the cycle time, and the tool capacity becomes the bottleneck. And so this is really an approach to be able to say, okay, be able to try to skip the measurement with an intelligent way of saying, oh, okay, that one's different. You should sample that one and actually measure it, and the rest can all get skipped, and we can get a much higher throughput on this tool. And so again, there's significant opportunities for value realization. They're a lot of the same as the AMQPIV project, and they're related to like throughput that I just mentioned. One of the other unique ones is like capital utilization. So if we can get more with the tools we have, we can put off buying new tools to increase our capacity, right? So if we can flow more materials, more product like through the tools we have as existing, then we can save on significant costs by putting off purchasing equipment and delaying that purchasing as well. That's a more unique one here. So the overall architecture for this particular project, you can see it's relatively similar, but there are some like important structural differences. So we're still reading from the same kind of live published queue, basically. So, a process tool completes, it will wrap up all of that data with the contextual information, and then it will publish that payload to RabbitMQ. We then read from that. We have a serverless function that will basically enrich that data with model information. So again, what models need to be applied to this data, adds it back to a V3AO stream. And then all three of these steps is like one DAG in Iguazio, right? So with the first step being common preprocessing for all models, basically. So it's going to convert the payload to a data frame. It's going to do a bunch of preprocessing, basically, that is common for all models. And then we have all of these models then loaded into memory. So with this one, it's very different than the on-demand serving. You're actually deploying like 4,000 models or more in memory. And then you're parallelly routing to each. So for this particular project, you need to be able to send messages to multiple models at a given time. So with this, you're able to route to each one of them, deploy them into memory. They can each do their own more customized pre-processing. That might be things like encoding categorical variables, filling nulls, or like imputing nulls, etc. And then predicting. From there, each of those, so this is like one step in the DAG. This is many steps in the DAG, and then it collapses back to one step, which will then write all of those results to the database, basically. So that's all handled through Guasio. The main benefit of that is like, you can create these complex, like I said, there's a steep learning curve to Guasio initially, but a lot of it has been mitigated and some of it is well worth it, if that makes sense. We have not met a deployment or serving architecture that we need to utilize that has not been able to be executed with Guasio, at least today. And we're doing some very complicated, uh, you know, for lack of a better word, strange things sometimes because of how the factory operates. And so they're very unique things that need to happen on the inferencing side. And we've been able to match that perfectly with what Guasio gives us for tools. So overall, you can see that the average duration for this entire pipeline, so when we receive the payload here to when we write to the databases, is about 6 seconds. And so this project in particular has a much lower, requires a much lower latency, where we need to give them a result as soon as possible. Like if we could shave a second off this, they're happy. For them to be able to determine if a wafer should be measured or not, so they can route it properly throughout the factory. Similar to this project scale, we're operating at like about 11K inferences per day across 2 different factories. There's a much less there's only basically there's about 4,600 models deployed into memory, and we're averaging about 6 seconds from receiving a payload to the result being written to the database. What also this is wonderful about is each of these can be scaled independently, right? So not every payload has a model, but we're receiving every payload from the factory, which is a lot. So this could be scaled up independently of the overall DAG as well. Kind of an idea. So challenges for this project, mainly the model artifact management. So versioning thousands of those models, each with their own unique labels and associated data. How we actually choose to deploy models is really important too. So like in AMKPIV, the first project that we discussed, it's unsupervised, right? So we're actually just taking the latest model, the model that was trained with the latest data. We're going to take that one. We have a lot of assumptions built in about and checks built in about the performance during training that get checked, at least in terms of like the error rate. The main pre-trained model over there is a convolutional autoencoder. That is the pre-trained model, at least. So there are a lot of assumptions built into that. And then we are deploying the latest model always, or we're taking the latest model as soon as it's trained. With this particular project, we're actually, we have a lot of criteria. So since it's a supervised classification problem that we're operating in here, we have a lot more metrics. So like we're basically ranking models based on time. So it is prioritizing the most recent one, but then we have a set of metrics that they have to meet above, like the true positive rate, false positive rate, etc., above or below to be able to be candidates for deployment. So we're basically, when a model gets trained here, there has to be a separate deployment script that gets kicked off afterwards to be able to then deploy those models into memory for serving. Like choose which models meet that criteria and then deploy them. Okay, and then yep, flexibility is super important. Like I said, with the parallel model routing, super important. Having that customizability with the DAG, so we can individually scale those components. A large number of small models being loaded into memory is not necessarily easy for a lot of systems. And Iguazu is making it even easier as the years go by. I think a lot because we're like really stress testing the system, and they've been very attentive to that as well. Um, and then low latency, which I mentioned. And then of course, the model monitoring and the resource monitoring has been super beneficial. So that applies to both projects. Like I cannot tell you how amazing it is to just be able to deploy something and already have monitoring in place and already have log generation, log forwarding in place. And I can easily make new dashboards in log forwarding or in Grafana. And Grafana already has customized dashboards out of the box, as well as set up alerts. I can set up an alert in Grafana in like 2 minutes to just check, hey, is this function constantly being invoked or not? And like shoot me an email or send me a Slack if it's not, something like that as well. So I cannot highlight how important and how impactful that has been as well. Okay, so in terms of the future of like MLOps and Seagate and working with Iguazio, we're still working towards more onboarding and education and collaboration and making that easier, more effective, etc. Going throughout. We're going to support and scale both new and existing machine learning projects or research. So there's a lot of research we have coming down the pipeline that we're testing out in Iguazio and beginning to work on, and really enhancing our reporting and automation as always, facilitating the adoption of these new technologies like LLMs and Gen AI. Again, it should not be understated the effect that there is so much, especially in the manufacturing space, that is not AI and ML related, right? So much of it is educating engineers. It's getting the actual technology in their hands in an effective way that they can actually make a decision. So it's like setting up the dashboard. What is their workflow for reviewing alerts? What is their workflow for actually making a change on a particular tool set? How are we going to take that tool set down? There's so much to the integration piece and to the actionability of the results that gets left out, or that can get sidelined if all you're focusing on is infrastructure and MLOps, right? So that's like a huge benefit that Iguazio gives us, is it frees us up to be able to focus on the implementation and the usage of AI and machine learning across Seagate. Well, Iguazio focuses on these new developments, like, okay, what does MLOps look like for Gen AI and LLMs, etc. So that's been hugely beneficial as well. Continue to engage with them to improve the existing platform and offerings and just continuously improve, and then enable innovation and remove kind of these barriers to implementation, which I just mentioned. So yeah, thank you for having me. That was a rough overview, and I'm sure we'll have plenty of questions throughout. I'll kind of hand it over to Glad for the actual demo that's coming next as well.
Thank you so much, Kaegan. That was really insightful and inspiring to see how Seagate has scaled and developed over the last 5 years, you said?
Yep, about 4 years, but yep.
Yeah, it's been quite a journey. So
Yeah,
thank you so much for that. Before we dive into the demo, before I hand it over to Gilad, I just do want to take 1 minute and launch the first poll. So if you can take a moment and let us know, what area do you find the most challenging when building out your AI factory? I know everyone is coming here from different backgrounds, but we'd love to hear from you. Is it model and artifact management? Is it handling high-scale operations or real-time anomaly detections? Maybe it's quick function deployment. Some of you may not have any challenges, which, if that's the case, wish I were you. Or some of you may not be currently implementing an AI factory. Maybe it's in the horizon and you've come to hear Kaegan and learn from his expertise. All right, so I'll stop sharing my screen and I'll hand it over to you, Gilad. Thank you so much.
So, hello everyone. As Edith said, my name is Gilad. I'm a customer success engineer from Iguazio, and I will show a simple example to demonstrate what Kaegan showed. As you can see, I have this project. I named it MLOps Live project. In this project, I have 1,250 models. In overall, I can see an overview and information about my project. I can see that I ran in the last 7 days couple of batch run to train my models. I have one real-time function that name serving, and I can see all the information about my model. Florian, you asked about if Seagate using Kubernetes and about the model registry. So Amaran is a model registry that you can register your model. So here you can see all the model that I registered, and by using Amaran, you can manage those models. You can decide which models you want to serve and to choose to add to your serving function, and I will touch it later. So for my models, you can see that I can that I have a unique name. This is the key. I can use tags, I can add labels, any other metadata that is relevant, and use this metadata or the name of the key to choose the model. On Seagate use case, they choose a couple of labels and they choose by the date and the tag, but you can choose whatever you want, and based on those details, select the model. And all the run and all the 7 functions are running on Kubernetes. This is an important thing, that the mindset when you develop on MLRun is a production mindset. From the smallest function to the largest functions, they all run on the cluster and they all behave like a production function. So as I said, here I can see all my 1000 plus models. And just to give a content that this is the notebook that I use to create to create this project. So I created the project, then I created my train function, and then, as Kaegan said, everyone integrate as a built-in integration to KFP. So it's very easy to take one function and run it in parallel. So I ran one workflow, one KFP workflow that train all those 1000 models. And once I have those models, I can create my serving model and add the model that I want to add to my serving model. In this example, because it's a simple example that we just want to demonstrate, so I selected all the models that I have in the project, and then I deploy the functions. Once I have the deployment in my Kubernetes cluster, I can send an invocation. The invocation can be sent with the internet, the internal URL or the external URL. It depends on the use case. And you can see that I can send different invocations to different models. For example, in this line, I'm using this model, and in the second cell, I'm using the second model. And just to see an example, you can see that I sent a lot of requests for all the models, and for all the 1000 models, it took only 12 seconds, 11.9. So this is like to give a little bit content about and a real life example, how if I take one component of Kaegan use case and how it's looking in Guasio. And Florian, you asked if the inference is in real time. So as the example showed, is in real time. So thank you very much, and Edith, you can take it.
So much, Gilad. It was really great to see the deep dive, running the modules in scale, and really helpful to see it in action. You know, it's amazing to take what Kaegan said throughout all of his slides and show it to us in a quick but impactful demo. So thank you so much. Before we move into the live Q&A, I just want to take a quick look at some of the questions that came in. All right, so a bunch of questions came in. We're going to try to answer as many as we can. And Kaegan, Gilad, if you see something that stands out to you, feel free to start. The first one I wanted to begin with, and I think is relevant for everyone, is Kaegan, from your expertise, to kind of hear from you. Someone asked, what are the key differences between MLOps and AI ops?
Yeah. So I mean, in general, I think that there's more similarities than differences, right? You are still going to be tracking some sort of artifacts and some sort of information along with your models. You want to be able to version those over time. So when you're talking about like LLMs and different generative AI kind of concepts, I think that it just becomes more customized, really. So, you know, in general, if you're doing any kind of fine tuning or anything like that, you might want to be creating artifacts for each of those layers. It just becomes more specific, really. And what's nice is that Iguazio has again kept up with that, right? So they have a lot of utilities for managing that are specific to LLMs, but still take advantage of a lot of their existing architecture and infrastructure as well. So I would say there's more similarities than differences. I consider MLOps a much larger circle and AI ops within that circle, if that makes sense, if it's a Venn diagram.
Yeah, that makes sense. A technical question here for Gilad. What's a typical model size? And it says here, what is a typical model size, which makes it possible to load thousands of them in memory?
It's important to say that, as I said, you are deploying things on Kubernetes. So if you allocate enough memory, you can load the amount of models that you want to load. Okay, MLRun support all kinds of all the number of the models that you want to load. It depends on the allocation and the number of the amount of resources that you allocate to the function. So you can choose whatever you want. Okay.
Okay, that's helpful to understand. And Kaegan, I don't want to reveal the poll results yet, but it is clear that a lot of people are, in their journey and looking to scale. So I wanted to kind of hear from you, with so many models in play, what's been the biggest mind shift that your team really has had to make in order to think of scale instead of thinking model by model?
Yeah, honestly, the biggest struggle for us, like since Iguazio is handling the versioning, right? That part of the scaling is already managed for you. Same with a lot of the Nucleo like replicas and functions and being able to train models in parallel. Like that is all handled for you. It's just about learning how to interact with it. The hardest part, honestly, from a scaling perspective, and biggest mindset shift is honestly the code. Like if you get it is a lot harder to productionize code that is not meant to be scaled than it is to productionize code that like has been made with deployment in mind, if that makes sense. So a lot of things might not be parallelized already and might need to be parallelized. A lot of times things might not be broken out into individually customizable components as well. So it might be more of like a monolithic code base that needs to be broken down for it to be effectively scaled, right? Like where you could break it into those, directed acyclic graphs and et cetera. So honestly, that I would say has been like a mind shift as a company and as a culture, is like trying to get more towards that software development kind of expertise and like best practices as well, and how much that relates to code. And the only reason that we can even focus on that is because Iguazio has already handled the other hard parts, if that makes sense. Like there's a really good paper from Google that I think a lot of people have probably read. It's about like the hidden costs in machine learning infrastructure and systems. But basically, it's just like how much of it is actually the code and how much of it is the infrastructure, basically. And so we're able to focus more on the small part that like because the bigger part's handled. If that makes sense.
So if I'm understanding you correctly, you're saying when you write the code to have that production first mindset, to really think
Yep.
about, yeah.
Yep.
Okay.
And that comes with time and experience, right? Like you just, the more things you deploy, the more flexible you get, and then like the more you try to learn about a lot of people in the machine learning and data science space are researchers first, or they come straight out of university, and some of them might not even know about Kubernetes or Docker. So like there's that level of learning that needs to happen, and then there's the software development expertise and learning that needs to happen. So it's like really juggling a lot of different hats. So it could be really hard. So like that has been it's like an unexpected challenge to try to solve, basically, because everyone thinks if I have code, I could just deploy it. But that's not always the case.
Yeah, that makes sense. There are a lot of questions that we may not be able to answer. I will be in touch with you afterwards and connect you to the relevant speaker. But I do, Gilad, want to kind of hear from you. What are some of, with all the experience working with different clients over the years, what are some of the key production roadblocks that you've seen that companies have faced, Seagate or other companies, and how have you helped them overcome these challenges?
So I know that we said it before, that I think the first thing is the production mindset that you develop, and you start to develop, and you think on the feature, on the function, as something that you will run in production. In MLRun and in Iguazio, we have a lot of features that use that help user to try and build things like a production from the development state, like logging and monitoring those issues, artifact management and versioning of those artifacts. Function versioning, so you have alert and model monitoring that you can take and monitor things and see how you can improve them. You can manage large scale with all the things that I said above, and because it's run on Kubernetes, so you have all the advantage that Kubernetes come from that Kubernetes have, and can help you to overcome those challenges.
It's nice to hear you guys are aligned. Sometimes
Yeah.
every company is different. Every company has their own challenges, but Gilad from the customer success side, working with many different customers from different verticals and different industries, and hearing you, Kaegan, specifically from Seagate, it's interesting and eye-opening to hear that same point. Last question we're going to take, and then I do want to share the polls. A specific one for you, Kaegan. Are you using your own model registry solution or an open source commercial solution specifically for model registry?
Yeah, so Glad touched on it briefly in his demo, but so Iguazio has its own model registry and database, so we're using that, of course. So basically, you run a job, you log your model, and whatever artifacts are associated with your model, it could be your training data set, it could be your again, like a categorical encoder or a imputer or something, any relevant artifact, any relevant file, any relevant data to that model. And then basically the model registry takes care of the rest. So your model will have a unique ID, it'll have unique labels and tags. And then you can use that to pull whatever models you want and whatever information you want and manage them over time, transition them from staging to production, etc. as well. So we're taking advantage of that one. I'm sure MLRun would work with an open source one if you wanted to, but if you have Iguazio, I would just use what it comes with, keep it all simple.
Great. Thank you so much. I want to just take a second as we wrap up and invite you to explore our website, iguazio.com. You'll find past webinar sessions along with a wealth of additional resources like blogs and case studies, best practices, and we'd love to hear your feedback as well. And I just want to give a really big thank you to Kaegan and to Gilad for your excellent presentation and demo. I know it takes a lot of effort and time and energy to prepare for this session. So I really, really, really do appreciate it. And we look forward, and thank you to everyone who took the time out of their day to join and hear our MLOps, our 36 MLOps live session. And we want to continue the conversation. If you haven't joined our MLOps Live Slack community, feel free to join that and continue the conversation. So thank you, everyone. And we look forward to seeing you at our next session.